and feature branches. Hi, my name is Alan Pita. I'm a consulting CTO, and here is my LinkedIn URL. Feel free to message me online. So a lot of software teams are using Git and Mercurial and a whole bunch of other similar tools. And when I first learned Git some years ago, it really wasn't clear to me why we needed these additional features that seemed to just be added complexity that Git offers. And even though a lot of software organizations have adopted Git and Gitflow or something like Gitflow on top of Mercurial or other alternatives, some hybrid organizations, particularly hardware software co-design organizations, have yet to adopt practices that look like Gitflow and feature branches. So I'm giving this presentation to talk to that audience and say, okay, software folks use this practice. Why do we even need it? All right? Why do we need feature branches and pull requests? So obviously we have multiple developers and engineers working at the same time, and they're working independently. They're working in parallel. We really don't want them to have to coordinate with one another on like the daily, right? The changes that they make should be, hopefully they're working on one ticket or one Jira issue at a time. But even though it's one ticket at a time, they may be working on changing files that overlap with files that need to be changed for other tickets. So we don't want to assume that if we have 5 different tickets that they're all going to be non-overlapping files, or that necessarily each person on the team or each pair of persons on the team own a distinct set of source files. Yeah, if you can manage that, great, but a lot of times that's not the case. So here's the heart of the problem. We all have to have a golden copy of the source code. Where is that golden copy of the source code? If we're engineers and we're starting some follow-on work, or we're working on a new ticket, what do we start with that actually is good and working? We need to know that what we start with when we're working on a ticket, that all the updates to the golden copy that we use as a basis work correctly, not just individually when you're looking at the change for that ticket, but that they work correctly once they're integrated together and the repository, nothing in it is broken by adding this change. This golden copy needs to include all the latest changes that have been reviewed, that have been approved, and also tested and passing. The changes need to be merged together. If there were any conflicts during that merge, those merge conflicts needed to be resolved. And hopefully, of course, that's a very rare circumstance. Even when you have overlapping files, Git is very good about figuring out how different lines change and just to stitch that stuff together without needing any user interaction. Once they've been merged together, we need to make that golden copy, the new golden copy, available to the whole team. So how do these changes that are being proposed for a Jira issue, be it a feature or a bug ticket, how do these changes for that Jira ticket get merged into the main working branch so that everyone can see them and use them? So there's an obvious approach, which is sort of using a shared master that basic Git offers you. It's tempting. There's also the alternative that most professional software organizations are using, which is Gitflow and feature branches. So let's look at the whys for both of those. In both cases, we start with a shared copy or clone of the repository that's stored on hosted Git. This may come as a surprise, but having a homegrown Git server is actually not more secure than cloud hosting. Cloud hosting your Git repository allows you, well, first of all, the copy is encrypted both in transit and at rest, so your cloud service that's hosting your Git repository, they can't see your code. And also, when you have engineers coming into and also exiting your organization on a regular basis, the cloud hosting version of Git really allows you better tight control over who has access at any given time to a copy of your Git repository. So that's why, in general, we recommend using cloud-hosted Git as opposed to a homegrown Git server. Now, also in both of these scenarios, both shared master and Gitflow with feature branches, everyone has a local copy or clone of the hosted shared repository. Now, the seemingly obvious alternative is to have a shared master branch in Git. That means that your master branch in Git serves as the golden copy, and anyone can merge their work directly into this master branch. Again, this seems obvious, but it actually scales very poorly. The thing that makes a difference is adding a review step, a lightweight, relatively non-intrusive review step just before the merge between individual work and group availability. We want to make sure, like I said, that this review step is minimally disruptive to the otherwise asynchronous and in parallel development engineering work. We don't want this to turn into a big roadblock for people to share their work together. And as evidenced by the fact that most software organizations are using Gitflow and feature branches, it really is very acceptable. It can be quite a minimal cost, okay? So that is the alternative that we're recommending here, is using Gitflow and feature branches. So in this case, rather than managing local work by committing to a local master and then pushing when you're ready to share, instead we use Git branches rather than local clones to manage dev work that's still in progress for a ticket that we're working on, okay? So there is a main branch. It's shared with everybody, and that main branch contains all of the latest reviewed, approved, tested, and merged work. We also create a feature branch for every issue that we work on. You can also call it a bug branch or an issue branch, but I call it a feature branch because that seems to be the standard terminology. So before you start your work, you want to create a feature branch, and I really recommend that you name that feature branch after the issue that you're working. Okay, so like issue proj-xxx is the branch that contains work in progress for Jira issue proj.xxx, where you replace proj with the slug for your Jira project, and xxx is the ticket number. It's also very common, although it's kind of apocryphal to this, it's also very common for us to create release branches because Git doesn't have tags the way that old previous or legacy version control systems had tags. Git just uses branches to represent tags. And so a branch named release/vxyz just tags what code was released in version XYZ. Okay. So again, all of the clones of the hosted Git repository, they have the same shared set of branch names. They all have main, they all have the same feature branches, they all have the same release branches once they've been pushed and pulled. You can always pull the main branch pretty much at any time and see the latest of what's been merged into the shared repo. And this is, to me, a side benefit of Gitflow and feature branches that maybe was counterintuitive and I didn't expect. Because you're not having to use a shared master and then wait to push to the shared Git repository until you're ready to share and you think everything is absolutely perfect and golden, because of this, because you have this feature branch that you're working on in private, whether it's local or whether it's pushed, you can commit as often as you like to your local clone of a feature branch, and you can push as often as you like to the shared repo all on your feature branch. So I find that very useful, and it actually frees me up to use the feature branch more liberally as sort of an undo or edit mechanism that is somewhat private to me or the people that I'm sharing this ticket work with. You can also push a feature branch from your local clone to the shared repo when it's still in progress. So you don't have to wait until it's in any state of doneness. You can push your feature branch at any time. And this is actually pretty good practice if for no other reason that when your laptop dies and you lose your if you've got hard drive crash or whatever have you, yes, we occasionally still have hardware failures, then you still have a copy of your work that's fairly up to date, even if your clone gets completely blown away. Or you lose your laptop, which some of us have done from time to time. There's other reasons to push your feature branch in progress to the shared repository, and that is to get feedback from a colleague. You can also use this as a mechanism to stash and retrieve your work for later if you need to pause and switch to some other work. You can also pass that partially completed feature branch to a colleague who will pick up that work and continue it. Now, necessarily, for Gitflow and feature branch to be the practice in your organization, your admins will set it up so that the main branch is protected. Only admins can write or merge directly to that main branch, and they really should only do this in case of emergency. regular production work, even if it's being contributed by someone who's an admin or a reviewer, should still be done via feature branch and pull request, okay? So developers and admins should create a pull request when they want their changes in a feature branch to be merged into main. Don't commit changes to main in your local clone. This is a pretty easy way to shoot yourself in the foot. It's not irreparable, but it's a little inconvenient to fix it. And if you do that, if you push changes to main in your local clone, and then if you commit changes to main in your local clone, and then you try to push that from your local clone to the shared Git repository in the cloud, you won't be able to push them because main is protected. So make that a habit as early as you can. And if you accidentally do that, there's a way to repair it retroactively. Just talk to your admins or reviewers to get that fixed and create a feature branch retroactively. So this is how you do Gitflow. In the basic case that you're starting a new Jira ticket, which is a feature or a bug, first of all, you either need to reuse a clone that you already have, or if you don't have a clone of the shared hosted Git repo, you need to clone it locally. Then, whether you're reusing it or you created a fresh clone, you should pull the most recent updates that were merged into the main repository the main branch from the shared hosted Git repository to use as a basis for your issue work. Then create that feature branch and name it after the issue, as we showed in the previous slide, in your local clone, and go ahead and do your development work. Make edits to as many source files as you want, run experiments, run tests, try to make sure that everything in your unit tests passes before you proceed. All right, I shouldn't say before you proceed. This step, you can do this before your unit tests pass. You should commit your changes to your feature branch in your local clone early and often. Your team may have specific rules about how often you need to commit your changes locally to the feature branch. I would say a minimum of once per day is what I recommend. Right? Now you can push your feature branch to the shared hosted Git repository anytime you want. Again, you don't have to wait until unit tests are done to push your feature branch. There's other reasons you might want to do that early. Now, before you open the pull requests, you do want to make sure that your unit tests are passing. If your unit tests are passing, or if there's things that your team lead has set aside as coding standards that will come out in review, you may get a little slap on the wrist if you open the pull request before those unit tests are passing, or before there are things that are done in your code that should have been corrected that are team standard practices that you already know about. Once those things are cleaned up to a minimum level, then go ahead and open that pull request and wait for reviewers to post comments. And also, if you have CI/CD, such as Jenkins or Circle CI or whatever, you'll also get automatic results from integration tests that will run as soon as that pull request is open. That happens because the pull request also happens to mention the feature branch and the Jira ticket in it. So CI/CD knows what branch to pull and what branch to run automatic integration tests on, right? So reviewers probably will make a few comments. Reviewers should review your code within a reasonable amount of time. Every team will have a standard for that. Best teams will have PRs reviewed within 24 hours or by the end of the day, okay? And then you, as the developer, need to go in and address any review comments and fix any test fails by making changes to your local copy. Then go ahead and go through your unit testing process, make sure that it's ready for review again. And once you're done, re-push your feature branch from your local clone to the shared hosted Git repository. Once all of those comments and fails are addressed, your pull request or merge request will be approved, and then that pull request will get merged into the main branch. This can either be an automated action, like all of these Git cloud services are able to be configured where the repository will the main branch will automatically merge a completed and completely passing, completely resolved pull request. That can be completely automatic, or as is the case when I set up a repository, it's just a push button approval action by the reviewer or the admin. So I just click that button once I see that all of the comments have been resolved and all the failing tests have been cleared and everything passes. So that was the basic Git workflow when you're starting work on a single Jira ticket. There's a bunch of useful variations that you do not need to master up front to get started working with Gitflow, but these are things that you'll get used to doing as increasingly unusual situations crop up. And it's okay to ask your admin for help with these. It's absolutely okay. Atlassian has great resources online explaining how to do some of these more advanced use cases, sort of these intermediate use cases is what I should call them. But eventually you learn to do them by yourself. Here are some of those useful variations. So you can use a feature branch as a place to stash and retrieve your work in progress. I use that quite regularly. It's also pretty easy to switch back and forth between branches and main. So especially when we're fixing bugs and that kind of whatnot, it can be very useful to look across branches and compare things. And just using command line Git or the most basic Git client, it's very easy to just switch branches and switch back to main or switch back to your feature branch. The only thing a caveat to that is before you switch branches, you have to commit everything that's dirty in your current working copy. You have to commit it to a branch, whether it's your feature branch or maybe it's a new branch you create just to stash things. You can't switch branches cleanly if you haven't committed your changes yet. So commit first and then switch things back and forth. You can always undo things later on if you need to. All right. Another time, we as developers, we always want to think that the first approach that we take to a ticket is going to work out and we don't have to reverse anything. But every now and then you'll get, several days or even a week into working on a ticket and realize, oh my gosh, this is really not working out. I have a bunch of commits here, and that's okay. These lightweight commits are what Gitflow is all about. But you know what? I just need to abandon this and start from scratch. I want to go back to main, pull it again, and start over. Okay, that's fine. It's easy to do with the feature branch. You just create a second feature branch. No big deal, right? So it's pretty easy to abandon a branch that didn't work out and start afresh on a ticket. Again, it's pretty easy to diff a file across branches, and even though the basic Git clients require you to switch and copy, IDEs like JetBrains or Visual Studio Code have really great GUIs for looking at file changes, comparing them across different branches. And that can be very helpful when you're, for example, working on a bug ticket and you need to understand upstream, like, okay, well, this bug seems to be related to this earlier ticket. Why did we make that change? So you look up the feature branch and that went with that ticket and say, okay, now I can compare that with main. What got merged? Did something get dropped? Did something get corrupted during integration? Or what was their rationale? So having that sort of comparative view across history is something that's really pretty powerful, and I definitely use that more than once a quarter, particularly as a CTO or software architect. You can also start a new feature branch, and this is a pretty advanced use case. I try to do this less than once a year, but I find that this use case is applicable when you have teams that are really pressing their schedule. So they're very aggressively trying to get stuff out the door. And so saving a day or two of latency by saying, okay, feature X got committed, got pushed, but it hasn't been merged yet, and we need to go ahead and start working on feature Y. We need to base feature Y off of feature X because they're sort of codependent, but dependent on one another, but we can't wait until feature X passes the full merge request or pull request process. So let's go ahead and base feature Y, the feature branch for feature Y, off of feature X. Okay, you can go ahead and do that. That's aggressive. There's risks and there's stumbling blocks that can happen when you do that, but it's entirely legal and Gitflow supports that. Personally, when I'm working with the team, I see that as a sign that the schedule is perhaps overly optimized and we need to look at refactoring our issues or just maybe looking at our commitments and trying to figure out, maybe we're overpromising a little bit. Okay, because everything in Git is basically just a history or log of commits, it's pretty straightforward to edit past commits. And I'm not just talking about editing the comments in the commits. You can edit every detail in a commit, and it's very interesting. I don't actually do this very often, but gosh, when you need it, you need it. This one's actually more common than some of the other ones. So squashing consecutive commits. So we had mentioned earlier that committing early and often to your local copy is useful. There's some side benefits to it, but having tons of extra commits, once you push that to, once that gets merged into main, all of those commits can show up as individual commits. And that means the commit log for the merged repository branch, that means that that commit log can get very long very fast. So sometimes it's useful to squash your commits. I've actually been on teams where there was a rule that before you finish a pull request, you need to squash everything together so that everything basically appears as if it was one commit once it gets merged into the main branch. And that's a perfectly good practice. I'm not strict about that, but merging commits is good. I've also seen squashing commits useful because sometimes if you're a vendor or if you're an IP provider, you might want to be able to share your Git repository with your client, but you might not want to share absolutely all of the details of every little bit of work that you did. So squashing commits allows you an editing phase where you can sort of hide some of the details that you don't necessarily need to share across company boundaries. So that's a very useful feature. But a lot of teams don't use that, and that's completely legitimate too. Now here's a couple of advanced variations. I mentioned that these intermediate variations are things that you can ask for help from your administrator if you run into these situations, but eventually you'll probably learn to do them yourself. These advanced variations are so infrequently useful that I sort of feel like most Gitflow users don't really need to learn to do them by themselves. These are situations that you may want to go ahead and call in your Git admin or your team lead or your reviewer and ask them to do the work here, or at least confer with them and say, hey, something weird happened here and I need to do one of these history rewriting things. And that's basically the gist of these advanced cases is you can rewrite history as much as you want. And of course, you can really shoot yourself in the foot and make things quite messy and nasty if you do that. So that's why I recommend getting the admin involved. But I find that moving the splice point between upstream and downstream branches is a use case. That's a set of use cases that are occasionally useful. Hopefully it's once or twice a year for your team and not like quarterly or daily. All right, so just remember that in Git, the state of a branch is nothing more than a head pointer to the end of a commit history in your clone. Now let's say that we have a branch N that is based off of a branch M. So we had branch M, we pulled it, and then we created branch N from branch M. So you can think of the N as splitting off of M. So we say that N is the downstream branch and M is the upstream branch. This one's actually really useful. So updating a feature branch. So let's say you've been working on feature branch X1. And let's say that, I don't know, it's taken you a few days to get to that. In the meantime, while you're working on feature branch X1, a bunch of other feature branches, Y1 and Y2, got merged into main while you were working on X1. Okay, well your feature branch X1 is based off of main, but it doesn't have those new merges in it from Y1 and Y2. So you have the ability to go in and pull the new changes to main, pull the new changes that have been merged into main, and then merge those changes back into your feature branch. So effectively now X1 has been updated, and now X1 also has Y1 and Y2. So that's a manual step that you have to do. And there's two different Git functions that can do that. There's a Git Merge and a Git Rebase. Git Merge basically appends the incoming feature branches Y1 and Y2 onto the end of feature branch X1. I think it appends. It may actually interleave them by timestamp, but I think it just appends them. And Rebase prepends Y1 and Y2 to feature branch X1. So a lot of teams prefer Rebase because it makes the history look like, oh, I actually started feature branch X1 after Y1 and Y2 were already merged. Sometimes teams just go ahead and use merge. I'm not religious about it. Some teams are. So as far as I'm concerned, you can use whichever works. Rebase may produce a cleaner history, but it also has a slightly higher probability of running into merge conflicts that you have to resolve. So just work with your team, work with your admins, or work with your reviewers and your team lead, and just figure out what the policy is there, whether you should update using Rebase or update using merge. I do recommend that you learn to do this stage before you open a pull request. That way you'll get the latest changes before you ask someone else to put eyes on your code, and you have less likely for it to get thrown back and have them ask you to do it manually, okay? This is the inverse case, and it actually corresponds directly to a gotcha that I highlighted earlier in this presentation. So if you forget to create a feature branch and you start committing changes to your local clone on the main branch, you will not be able to push them. This is the way that you would repair it. So the way you would repair it is you can create that feature branch retroactively, and then you can tell your local clone to reset that main pointer to undo some of the changes. So you're basically taking that main commit history pointer and putting it back where it should be. So what you end up with in the end is a feature branch and a main that look like you created the feature branch when you should have before you committed any changes. And that's the way you would repair it. Again, it's completely okay to ask your admin, your reviewer, or your team lead to assist you with this. It's a minor bit of surgery, and so don't be afraid to ask for help. Right? So that's our talk on Gitflow and feature branches, why we're using it, how we're using it. Again, Atlassian has some really good online written tutorials that or education information you can read on the web. There's a link right there for the article about feature branch workflow. And here's also my LinkedIn. Don't feel hesitant at all to contact me by messaging me on LinkedIn. Thanks for your time and have a good day.